So in today's video, we're going to go through this grade 9 circle question. So let's just get started. So it's given us the equation of the circle, x squared plus y squared is equal to 4. And it's saying find an equation of the tangent at C, and it's given us the point of the tangent. And it's telling us that P is greater than 0. And it wants the answer in the form y plus root a x equals b. Now, let's start with actually working out some unknowns. So this is an equation of a circle. Let's write out the general form of an equation of a circle. So we know the general form is x minus a squared plus y minus b squared equals to r squared. So that's what we know. Now, AB is the center of the circle. Now in R1, we don't have an A or B. So in other words, our AB is 0, 0. So the center of our circle is 0, 0. And the general equation is x minus a squared plus y minus b squared equals to r squared. So it's equal to r squared. Our r squared is equal to 4. Therefore, r is equal to 2. So the square root of 4 is just 2. So we know r equals 2, our center 0, 0. So I'd advise with these questions, always make a little sketch. So let's start with doing our little sketch. So I'll just draw it here. So I'm just drawing a rough coordinates axis and a rough sketch of my graph. So it's a circle. The center is 0, 0. So that's my center. And it's told us, find the equation of the tangent to C at the point P1. So I'm just going to put my P1 over here. So that's the point P1. Tangent of a circle means it's a line that touches the circle at exactly one point, and our point is P1. So we just have to make this straight line. So just imagine it's only touching at one spot. Now we need to think to ourselves, how can we relate tangents of circles with circles? Now you might remember a circle theorem. So you might remember a circle theorem when a radius meets a tangent, it forms a 90-degree angle. Now, 90 degrees means perpendicular. Now, let's see what we have. We have a line here. We have a line here. They meet at 90 degrees, meaning they are perpendicular. So how can we relate two lines that are perpendicular? So perpendicular lines. A fact we know about perpendicular lines is that the gradient of one of them multiplied by the gradient of the perpendicular is equal to -1. Or in other words, they are negative reciprocals of each other. So if we are able to work out the gradient of this radius line, then we would be able to figure out the gradient of the tangent. Now, we need to just look at what is given us. So we know it's given us a point P1. So let me just put the question here again. So let's just put the question right there. And now we know this point P1. So here's the sketch of the circle. This point P1 lies on the circle and is on the tangent. So it's right there. Let's work out what that is. So we know x squared plus y squared is equal to 4. And we know P1 lies on the circle. So wherever we see x, we will replace with P. So we're going to do P squared, and y is 1. So plus 1 squared is equal to 4. Rearrange that, and we get P squared is equal to 4 take away 1, which is 3. Therefore, P is positive root 3. It's a positive root 3 because P has to be greater than 0. Now we know what the point on the tangent is. We know it's P1 and P is root 3. So we know it's root 3, 1. And we also know the center of the circle is 0, 0. Therefore, we can work out the gradient of this line. So we know 1.00, the other point is root 3, 1. So let's do y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1, which just gives us 1 over root 3. Therefore, the gradient of this line is 1 over root 3. But we want the gradient of the tangent. So just remember earlier, the gradient of the tangent would be the negative reciprocal of this. It would be the negative reciprocal of this. So what we do is we flip it. So it becomes root 3 over 1. And then we change the sign. So that's just equal to negative root 3, which is the gradient of the tangent. Now, the last step is working out the equation of the line, and we need it in the form y plus root ax equals to b. So we're just going to simply do y equals mx plus c, and we sub in a point that's on the tangent. We know this coordinate, so P1, which is just root 3, 1, we know this lies on the tangent, so we're just going to sub that in. We also know m, which is the gradient, is negative root 3. So instead of y, we're going to write 1 equals. Instead of m is just negative root 3. Instead of x is positive root 3 plus c. Now let's just work that out. We get 1 equals negative root 3 times root 3 is just negative 3 plus c. When we rearrange this, so we add 3 to both sides, we get c equals 4. So the equation of our line is y equals mx, or m is negative root 3, so negative root 3x plus 4, but they want it in the form y plus root ax is equal to c. So we rearrange that, we get y, we add root 3x to both sides, so y plus root 3x is equal to 4. And that is our final answer. This question was testing your knowledge of circles, of circle theorems, so equations of circles, circle theorems, lines, perpendicular lines, and how you can link all of that information together, making it a grade 9 question. So follow for more of this style of content where we will be going through problem solving questions, grade 9 questions, as well as topics, and see you on the next video.